He'd imagined something traveling alone through the black ocean of space for millions, maybe billions of years. A silent wanderer, crossing the distance between stars with no map, no destination. It moves so fast, it could cover 6 football fields in the blink of an eye. In late 2017, it slipped into our solar system without warning and vanished just as quickly. It didn't look like anything we'd ever seen. It didn't move like anything we understood. And even now, scientists still can't agree on what it truly was. A rock, a fragment of an alien world, or something far stranger. October 2017. On the volcanic slopes of Haleakala in Hawaii, the Pan-STARRS telescope scanned the night sky as it did every evening, hunting for asteroids that could one day pose a threat to Earth. That night, something unusual appeared, a faint point of light moving just a bit too quickly and coming from an odd direction. At first, astronomers thought it was just another near-Earth asteroid, but within hours, calculations told a different story. This was not an object from our solar system. Its path was hyperbolic, the kind of orbit that comes from far beyond the sun's influence. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first. And it was more than just a new discovery, it was history. This was the first confirmed interstellar object ever detected by humanity. Only 3 such visitors have ever been spotted. Oumuamua was the first, and in many ways, the strangest. Scientists had only a short window, mere weeks, to study it before it slipped away forever. And in that time, it would challenge almost everything we thought we knew about the space between the stars. The Pan-STARRS survey's job was clear: spot potentially hazardous asteroids early. But sometimes, its gaze captured the unexpected. On October 19th, 2017, data began streaming in for a newly detected object, labeled A2017U1. At first glance, there was nothing remarkable, just another tiny moving speck against the stars. But Canadian astronomer Robert Verick, reviewing the images, noticed something odd. Its trajectory was wrong. Asteroids orbit the sun in ellipses. This object wasn't looping, it was cutting through. When the orbital eccentricity was calculated, the number came back as 1.2. Anything above 1 means the object is unbound, a traveler passing through once, never to return. The speed confirmed it. Over 196,000 miles per hour relative to the sun, far faster than any asteroid could naturally achieve within the solar system. Word spread quickly through the astronomical community. Karen Meach at the University of Hawaii recalled the moment she saw the data. This is the kind of thing you wait your entire career for. What made the discovery even more intense was the timeline. Oumuamua had already passed its closest point to the sun 6 weeks earlier. Every hour that passed, it moved further away, growing fainter. The race was on. But the first close observations revealed something that made it even stranger. Oumuamua wasn't just fast. It was coming from a direction almost perpendicular to the orbital plane of our solar system. Imagine the planets all orbiting in a flat sheet, and then picture something diving straight through from above, tracing its path backward. Scientists found it appeared to come from the general direction of the constellation Lyra. But after millions of years in interstellar space, its true origin was impossible to pinpoint. For centuries, astronomers had speculated about wandering interstellar rocks. The math suggested they should exist, fragments of planets or comets ejected from their home systems, but none had ever been seen until now. And seeing one up close was different. Here was a physical piece of another star system, drifting through our own. It was like finding a message in a bottle washed ashore from an ocean no one had ever crossed. The sheer rarity was staggering. Based on its detection, some estimates suggested that for every cubic astronomical unit of space, there might be thousands of similar objects, but only a tiny fraction ever cross Earth's path close enough to detect. Oumuamua was one of them, and it wasn't done surprising us. As telescopes tracked it, astronomers noticed that Oumuamua's brightness varied dramatically, sometimes by a factor of 10, as it rotated. That meant its shape was highly elongated, perhaps 5 to 10 times longer than it was wide. Most asteroids are roughly spherical or potato-shaped. This was different. Early models imagined it as a long, cigar-like object. Later studies suggested it could be more like a thin, flat pancake. Its spin period was around 8 hours, but it also seemed to be tumbling chaotically, not spinning smoothly like most space rocks. This non-principal axis rotation hinted at a violent past, perhaps a collision before it was ejected into interstellar space. Its color was another clue, slightly reddish, similar to Kuiper belt objects at the outer edges of our solar system. That color often comes from organic-rich compounds on the surface, altered by cosmic rays over millions of years, and yet there was still no sign of a comet-like tail or halo, no dust, no gas. For something passing this close to the sun, that was unusual. The next piece of data would make the mystery even deeper. Precise tracking revealed that Oumuamua was accelerating slightly as it moved away from the sun. For a comet, that's easy to explain. Sunlight warms the ice, gas jets erupt, and the object gets a push. But here's the problem. No jets were visible. Sensitive instruments saw nothing. This meant one of two things. Either it was producing outgassing in a way we couldn't detect, or something else was pushing it. Some scientists suggested it could be venting pure hydrogen, which would be invisible to our telescopes. Others proposed exotic ices like nitrogen. Then came Avi Loeb's headline-making idea. What if it was being pushed by sunlight itself, like a solar sail? If Oumuamua was a thin, light sheet, only a fraction of a millimeter thick, it could accelerate from radiation pressure. That, Loeb argued, might point to artificial origins. Most of the scientific community was skeptical, but everyone agreed on one thing: the acceleration was real, and that alone made Oumuamua unlike anything we'd seen before. Theories about Oumuamua's origin multiplied almost overnight, each with its own set of strengths and flaws. Some researchers envisioned it as a shard from a much larger planetary body, torn apart when it passed too close to its parent star. Such tidal disruptions can fling debris into interstellar space, where it wanders for millions or billions of years before encountering another star system. Another idea painted it as an iceberg, composed of exotic ice, perhaps hydrogen or nitrogen, that could sublimate invisibly in the vacuum of space. If true, it would explain the acceleration without producing a visible tail. The nitrogen ice hypothesis suggested it might be a fragment from the surface of a Pluto-like exoplanet, chipped away during a collision and ejected at high speed. But there were problems. Hydrogen icebergs would likely evaporate long before reaching us. Nitrogen fragments would erode over eons, making their survival across interstellar distances questionable. Then came Avi Loeb's now famous solar sail theory, that Oumuamua might be a thin, light structure designed to harness radiation pressure from starlight. Loeb argued that civilizations capable of interstellar travel might send out probes that look nothing like the spacecraft we imagine. And if such probes were abandoned or damaged, they could drift through space like cosmic litter. The idea captured headlines. Some scientists supported exploring all possibilities. Others dismissed it as speculation without solid evidence. The debate spilled into academic journals, conferences, and mainstream media. What made the discussion so intense wasn't just Oumuamua itself. It was the realization that we had no precedent for it. This was a completely new category of object, and with Oumuamua already speeding away into the darkness, there would be no second chance to gather definitive data. It left us with a rare situation in science, a mystery that might remain unsolved. Not because we lack ideas, but because the evidence is already gone. And yet, its legacy didn't vanish with it. In fact, it helped spark a new era of exploration. 2 years after Oumuamua's departure, in August 2019, an amateur astronomer from Crimea named Gennady Borisov spotted another fast-moving object through his backyard telescope. This one, later named 2I Borisov, was clearly a comet, with a bright coma and a long, streaming tail. Unlike Oumuamua, Borisov behaved exactly as expected for a body rich in volatile ices. It outgassed visibly, producing a spectacular tail as it approached the sun. Spectral analysis showed it contained the same basic ingredients as comets in our own solar system: water, ice, carbon compounds, dust. The contrast was striking. Oumuamua had been dry, silent, and strangely shaped. Borisov was active, luminous, and ordinary in structure. This raised a tantalizing question. Are interstellar visitors as varied as the worlds they come from? Astronomers believe the answer is yes. In fact, current models predict trillions of interstellar objects drift through our galaxy at any given time. Most are the result of gravitational chaos during the birth of star systems, comets flung into deep space, asteroids sent tumbling between the stars. The fact that we'd spotted 2 within just a couple of years suggested something profound. Maybe these visitors are far more common than we thought, and our technology simply hasn't been good enough to notice them. The discovery of 2I Borisov confirmed one thing: we were entering a new chapter in astronomy. The hunt for interstellar objects was no longer hypothetical. It was real. And every new detection would bring a fresh opportunity to compare, contrast, and refine our theories about how star systems form and evolve. But here's the catch. To truly understand them, we can't just watch them pass by. We have to go after them. Which is exactly what some space agencies are preparing to do. Catching an interstellar visitor in real time is one of the most challenging goals in modern astronomy. These objects are fast, faint, and often detected only after they've already passed their closest point to the sun. To solve this, agencies like the European Space Agency have designed missions that don't wait on Earth for the next discovery. They wait in space. One of the most promising is the Comet Interceptor, set to launch later this decade. Instead of heading toward a pre-selected target, it will park at a gravitational balance point, the L2 Lagrange point, and lie in wait. When a suitable object is detected, whether it's a long-period comet from the outer solar system or a true interstellar visitor, the spacecraft will sprint to intercept it, capturing images, spectra, and possibly even deploying smaller probes to fly alongside it. The upcoming Vera Rubin Observatory will play a key role in this hunt. With its massive mirror and rapid sky-scanning capabilities, it will image the entire visible sky every few nights, vastly increasing our chances of spotting the next Oumuamua early enough to react. Imagine for a moment what that could mean. A mission that approaches an alien object while it's still close, mapping its surface in detail, sampling its composition, and watching its behavior as it interacts with the sun. That's not just science, that's exploration at its purest form. And beyond the data, there's something deeper. These visitors are messengers from places we may never reach. They carry the chemistry, the history, and perhaps even the building blocks of life from other corners of the galaxy. Studying them isn't just about knowing what they are. It's about understanding where we all come from. One day soon, we might not just watch a visitor pass by, we might meet it, study it, and finally unlock the secrets it carries. Oumuamua came without warning, stayed only briefly, and left us wondering. It reminded us that our solar system is not an island, it's part of a larger ocean, where travelers from distant shores occasionally drift by. It carried secrets from another star system, secrets we may never fully uncover. But maybe the next visitor is already on its way. If this journey through the mystery of Oumuamua pulled you in, hit that subscribe button, give this video a thumbs up, and share it with anyone who loves a good cosmic mystery. And drop a comment. Do you think it was just an unusual rock or something more? Either way, well, keep looking up.